Now the Faraday experiment 2. In this experiment we take two coils. One is primary coil with battery, secondary coil with galvanometer. In Faraday experiment 2 we take two coils. One is primary coil with battery, another one is secondary coil with galvanometer. Okay, when current passing through the primary coil as per the Eirsted principle, when the current is passing through the coil along its axial line, magnetic field is established or magnetic flux is established. When the current is passing through the primary coil along its axial line, magnetic lines of forces or magnetic flux is established. Now we take the secondary coil with galvanometer nearer to this as shown in the figure. Now the primary coil is moves towards the secondary coil. When it is moves towards the secondary coil, this magnetic flux associated with this coil is varies or increases. When it is moves, flux is increases or varies. When the varying magnetic flux is linked with the secondary coil, in it induced EMF is established. In which direction induced EMF is established? In the opposite direction of association of magnetic flux. This is happened in the experiment 1. Here also it is happened. In experiment 1 we are shifted the magnet, but here magnet is not shifted. The coil is shifted towards the secondary. Immediately in the secondary coil, the association of magnetic flux is varies or increases. Immediately induced EMF is established in the secondary coil in the opposite direction of the motion of the primary coil that I mentioned here. Consider a primary coil with battery, and secondary coil with galvanometer G. Secondary coil with galvanometer G as shown in the figure. See the first sentence. Consider a primary coil with a battery. Primary coil with a battery and secondary coil with galvanometer as shown in the figure. Now, current carrying primary coil. This is current carrying primary coil. Current carrying primary coil produces the magnetic flux. Current carrying coil produces the magnetic flux along the direction of flow of current. Along the direction of flow of current, it produces the magnetic flux. By moving this coil towards the secondary coil, induced EMF is established. Due to association of magnetic flux in an opposite direction of motion of primary coil. Okay, where the induced EMF? The induced EMF is established. Secondary coil means by moving the coil or this coil towards the secondary coil, induced EMF is established. Where it is established? In the secondary coil due to association of magnetic flux in an opposite direction of motion of primary coil. Means the primary coil moves in this direction, induced EMF is established in this direction. Why? When it is moves in this direction, association of the magnetic flux is changes, so it is linked with the secondary coil. Immediately in the secondary coil, induced EMF is established, but in the opposite direction of the motion of the primary coil. Okay, if the primary coil is away, means when it is moves in this direction, what happened? Induced EMF is established in this direction. Okay, when the primary coil is moves in this direction, induced EMF is established in this direction. It is also proved by the Faraday in the second experiment. If the current carrying primary coil is away from the secondary coil, the current carrying primary coil away from the secondary coil, again what happened? Induced EMF is established in it. Induced EMF is established in it due to association of magnetic flux by the motion of the primary coil, again in an opposite direction. Okay, in an opposite direction. Okay now? Okay, this is happened. Induced EMF established due to the association of magnetic flux by the motion of primary coil in an opposite direction. Means here also, means in this experiment also, induced EMF is established in the coil due to association of magnetic flux in an opposite direction. In an opposite direction. This is very, very important. Okay. So, in the Faraday experiment, in the Faraday second experiment, in both experiments, induced EMF is established in the coil when it is associated with varying magnetic flux, but in the opposite direction of variation of magnetic flux. This is Faraday second experiment.